Hello everyone. We are a team from Breva University who are here today to present our project which we have developed. I, myself, Pamana Shivaram, student of Breva University, will be presenting a project on behalf of my team. Before I start off my presentation, I would like to introduce my teammates and authors of this project. We have Shruti S. and Suhasini S. Hosmani, students of Reva University. And I would like to specially thank Professor Sunil Manoli and Professor Chaitra M.H., faculties of Reva University, who have been a big support and guide throughout our project. Now, I would like to start off with my presentation. We have developed a project based on IoT, and a project title is Robotic Control System Car based on IoT. Throughout the presentation, I will be talking about the topics such as abstract, introduction, literature survey, problem statement, objectives, proposed system, architecture diagram, methodology, result and discussion, conclusion and references. These are the topics which will be discussed in this presentation. Now, I would like to start off with the abstract of the project. The purpose of developing this robotic car is to achieve low cost and low power. This robotic car gives the user a stress-free and calm driving. We have worked on the functions of the robotic car, which will detect the obstacle, records the image of the obstacle for few seconds and stores it into the cloud Dropbox. It navigates and controls the movement itself. It checks the surroundings with the help of ultrasonic sensors. The input is taken from the ultrasonic sensors. It analyzes the objects and reports it to the Raspberry Pi. Further, Raspberry Pi gives commands to the motor driving accordingly to navigate. Coming to the introduction of a project, it says as robotic car is an automatic vehicle that is designed to travel between destinations without human interaction. About 1.24 million have been killed on roads throughout the year due to accidents. The car, which has been developed, is an answer to the present drawback. Safety, congestion, value, and parking problems are resolved by designing this robotic car. According to the literature survey, we have done researches on 3 papers. The first one is the Google Autonomous Car. The limitation of this research are when the car is traveling at high speed, the car will be hardly able to differentiate the objects on the road. The second one is real-time visual marker detector and tracker based on computer vision for semi-autonomous convey purpose. The limitation of this research are using 320 by 240 low resolution of captured frames, which will cause the result inaccurate. Another research was done with the title Autonomous 3-Wheel Robot with Computer Vision System. The research is based on 3-wheel robot with computer vision. The weakness of this research is having a bad report or bad control method which can change to Wi-Fi control that can support higher control range. Keeping in view the current autonomous car, the drawbacks such as accident, liability authority, less security, wireless range is too small, no video surveillance systems are the drawbacks which has been found in the literature survey. All these flaws are taken into consideration and we have designed a project in such a way that all these flaws will be cleared in this. Objectives of a project goes like this: to produce an automated car, to make the car navigate itself when an obstacle is detected in forward motion, a video is recorded and stored in the cloud Dropbox. If obstacle is detected behind, then alert message is sent to the user. The main goal of self-driving automated car is to avoid accidents. Next, coming to the proposed system, in our proposed system, we have implemented a video inspection, where the video inspection is the process of auditing a situation, an area, or a person. The control mechanism is given a video transmission facility. The video convenience is practically achieved through high-speed video transposal. Initially, the robot will be attached with an ultrasonic sensors which detects the obstacles, records the video via the camera for 5 seconds and transfer it to the cloud Dropbox. It is also attached with the IR sensor, which allows it to detect the obstacle approaching the vehicle from behind. If the internet connectivity isn't available, still the unit can be used using Wi-Fi connections. It implements a system which is portable, low cost and having less maintenance. Here is the architecture diagram of our project. It includes power supply, Wi-Fi dongle, Raspberry Pi 3B Plus, LCD, which is nothing but the system which we'll be using for a demo. We have ultrasonic sensor at the forward motion. We have IR sensors at the backward motion. We have a motor driver attached with two DC motors. And we also have a cloud in which the video which is being recorded is being stored in this cloud. This is the methodology of a project. The combination of Raspberry Pi ultrasonic sensors helps in getting in the input. PC handles multiple tasks, that is receiving data from the Raspberry Pi, object detection and sending instruction to motor driver circuit to navigate. Ultrasonic and IR sensor detects the objects and helps in taking diversions. Camera records the video for 5 seconds and stores it into the cloud Dropbox. Once the obstacle is detected from the IR sensor present behind the car, an alert message is sent to the user mobile number. OpenCV acts as trainer and detector. This is the algorithm for a project. Now, at the beginning, when it starts in the forward motion, suppose the range is less than 15 centimeter, the obstacle will be detected and the car will stop. After the car stops, it will record the video for 5 seconds and it uploads the video into the cloud Dropbox. And then, according to the commands which is being given by the Raspberry Pi, either it will turn left or either it will turn right. Now, if the sensor detects the obstacle from the backward and the range is also a bit less than 15 centimeter, it sends the SMS to the mobile and the car stops. This is the code in which the ultrasonic sensors, the Raspberry Pi, IR sensors, in which according to the pin numbers, it has been attached. This is the code for forward motion. If the output is 10, it goes forward, and for backward, if the output is 01, it goes backward. For the left side movement, the code will be 00 or 10, it takes a left turn. If the code is 10 or 00, it will take a right turn. When the output is completely 0, the car will stop. This is the code when the obstacle is encountered in the front, and this is when the obstacle is encountered behind the car. And here, when the in this code, the recording of the detected obstacle happens. And here, the recorded video will be stored in the cloud Dropbox. Now, coming to the result of the project, we have successfully succeeded with the forward motion, backward motion, left rotation and right rotation of the car. And these are the outputs which we'll be getting. And if the car is in the forward motion and obstacle is detected in the forward, it will record the video for 5 seconds and it will upload it to the cloud. And if the obstacle is detected at the backward, it will send an alert message through an SMS to the mobile of the user. This is the operation model. We get the states of the vehicle, that is only whether the vehicle is either pushing ahead, in reverse, left, right, or the vehicle is in fixed mode. This picture represents the car is in the forward motion. This picture represents when the obstacle is detected behind the car and has been sent an alert message to the user. This picture shows the alert message has been received. Here is the video surveillance which has been recorded when an obstacle is detected. And this detected video has been uploaded on the cloud. Hence, I would like to conclude the whole project that in our project we have implemented an autonomous robotic car which helps in movement of car automatically. The car moves in forward motion once the power is given. In the forward motion, if an obstacle is detected, then a video is recorded for 5 seconds. This video is stored in the PC as well as the video is uploaded to the cloud Dropbox. In forward motion for obstacle detection, we have used ultrasonic sensors. In backward direction, we have used IR sensors for obstacle detection. If the obstacle is detected by IR sensors, then a SMS is sent to the user mobile number. In this way, the motion of the autonomous car works. Thank you so much.